All right, it is the Friday of prom, so I know a bunch of y'all are excited, but we still got stats to learn. Month till the AP exam, so let's knock out a couple check your understanding questions to help you prepare for the upcoming test next Wednesday. Again, that's getting pushed back a little bit because we also got the ACT next Tuesday, things like that. Got to take advantage of the technology we have for sure. All right. Here is, let me check to see if there's actually that's 9.6 or 9.7. We need to look at 9.6 from mathematic. Gonna start there. This one is all about type 1 and type 2 errors. I'm gonna go ahead and turn my video off so that I can flatten the screen out and write easily on my computer. So starting here, that was not intentional. All right, there we go. So Mr. Wilcox purchased a trick coin that is supposed to land heads up 75% of the time. One of his students volunteers to test this claim. Student flips the coin 50 times and finds the coin lands heads up 35 times. Now, one thing I want to point out, because I feel like this is something that I lost sight of for a long time when I first started teaching AP statistics. Don't know if I ever saw that for the um, when I was a student taking this class, but it's important to recognize that what we're doing is we're saying, hey, this coin is flipped 50 times. So we're looking at a point on a sampling distribution. That's how we set up all of our hypothesis tests, all of our confidence intervals. This one point estimate is on a sampling distribution with a sample size of 50. And so that's what is really happening when we do these inferential procedures. So describe, now we're just focusing on errors, but I want to bring it back to that to make sure that that's clear. So we're trying to describe a type 1 and a type 2 error in this setting. So as I reminded you, or as I've shown you in class, the thing that helps me understand a type 1 error, which then helps me understand the type 2 error, is this. I have some initial hypothesis, P naught. And if I find a statistic in this region right here, we're saying that this is where the alpha is 0.05. That's when I reject my null hypothesis that in this case P equals 0.75 because it's just not plausible. It is possible to get a value in that region, but it's not plausible. But there's still a chance that my initial hypothesis was correct. And so remember, alpha is the probability of a type 1 error. And so when I am trying to figure out what the errors would be, if I get into that region where alpha is 0.05, that means I've rejected the null, but there's a chance the null is true. And so that helps set me up to understand how to write about these errors. So in this case, for a type 1 error, I am going to conclude, if this will erase, I promise I know how to spell error. Well, let's just, there we go. Type 1 error, we believe the true proportion of times this coin will land heads up is less than 0.75, right? We are rejecting the null hypothesis that P equals 0.75, but P actually does equal 0.75. That's my type 1 error. And so when I now think about my type 2 error, So if type 1 was rejecting the null, type 2 error has to start with we fail to reject the null. So we believe. Notice I never say anything about proving. Remember, in statistics, we don't prove. If we could prove, that would solve a lot of problems, but we're having to do inferential statistics because we don't have a census. As soon as you can do a census, all of this work goes out the window. But in this case, we believe that we're failing to reject the null. So we believe the true proportion. Notice I really just needs to have context once. Why are you not erasing? That the true proportion of times the coin lands heads up is 0.75, but the truth is P is less than 0.75, right? So we made an error. We believe the true proportion is 0.75. We failed to reject the null hypothesis, but um, the alternative is true that P is less than 0.75. All right. So which type of error may result in Mr. Wilcox returning the coin and writing a negative review? Well, if he believes that the true proportion the coin lands heads up is 0.75, he's not going to return the coin, right? So that's not a type 2 error. This would be a type 1 error. He believes the coin doesn't work as advertised. P is less than 0.75. All right, there we go. If, hold on one second, let me check something. All right, not sure if you could even tell that anything happened, but I had to go take care of a couple things, and apparently half my work just went away. So hopefully you can go backwards in the video and watch that if you needed anything from number 1 and 2. But number 3, if the student were to use alpha equals 0.05 instead of alpha equals 0.1, would this make it more likely or less likely to reject the null hypothesis when the null hypothesis is true? So again, I'm going to go back to my normal distribution to make sense out of this. So if here's my initial hypothesis and here's an alpha, notice that region's bigger of 0.01 in comparison to, say, the smaller region where alpha is only 0.05, and that's the probability of me making a type 1 error, right? The null hypothesis is true, but we're rejecting. Alpha equaling 0.05 would result in a smaller chance to reject the null hypothesis. I think mathematic technically doesn't introduce the idea that alpha is the probability of a type 1 error until the next lesson. I go ahead and start with that from the beginning, so that's why that kind of seems redundant, but that's probably to set us up for the next lesson. So moving into 9.7, let's look at these questions to help us understand power a little bit better. So, a high school student is planning a very large graduation party. Again, by the way, this is the check your understanding for 9.7. She needs to know how many people are planning on attending in order to estimate the cost of the party. She plans to select a random sample of 25 guests that were invited to the party and record whether or not each person plans to attend the party. She will then test this null hypothesis, P equals 0.75 versus P does not equal 0.75, where P is the true proportion of all invited guests who will attend the party. She will use alpha equals 0.05. Now, suppose the true proportion is actually zero point 0.7. Well, in this case, that is definitely when we should reject the null hypothesis. The truth is that p does not equal 0.75. Now, as a side note, there are certain times when you need to think, is it genuinely a big enough difference for us to care? Personally, in that case, I wouldn't. But that's kind of where this idea of power comes in. So the power of the given significance test is zero point 0.1. Now, remember, we talked about power as the, oh, you know what I just remembered? I should probably go up and do quick notes because we didn't get a chance to do that in class before the DYU. And so I'm going to add some quick notes here to help you better prepare for the check your understanding. Recording progress. Okay, so obviously this is not my own handwriting. I'm just going to refer to this because it'll help establish some major ideas in a quicker way. So notice, to go back to the understanding of power, we go to that two-way table of there's a decision, we either reject the null or fail to reject the null, the truth, the null is true, or the alternative is true. And so we've looked at it. If we reject the null and the null is true, that's a type 1 error. If we fail to reject the null and the alternative is true, that's a type 2 error. Now, if we fail to reject the null and the null is true, we're good to go. The focus right now is, what if we reject the null hypothesis given or and the alternative is true? Well, that's where the power lies, right? The power is, again, that idea of, and I kind of like it what they show over here on the right hand side in the notes, of the probability that the null hypothesis is true given the alternative is true. So the probability, and I think this is the cleanest way to understand it, it is the probability of correctly rejecting the null hypothesis. Not sure if I read that somewhere or if I made that up or I heard someone say it, but that's been the way that it's always resonated with me. So, all that to say, we talked about this in the past. Down here on the left, the probability of a type 1 error, that's alpha, right? The probability of a type 2 error is 1 minus the power. The one of the things to remember is, if the alternative is true, there's only two things that can happen. Either we can make a type 2 error given alternative is true, or we can reject, or no, yes, reject given the alternative is true. Those are the only two options. When the alternative is true, those two things have to add up to one. So the idea of the power, the probability of rejecting when the alternative is true, that's just one or the probability of a type 2 error. Remember, we called that beta in class. Um, that's just 1 minus the power, which also means power is 1 minus the probability of a type 2 error. More importantly, on the AP exam, you got to know how to interpret, right? So if the alternative is true, given the alternative is true. And so you want the specific value in context. So if the alternative is true, or is truly P equals blank, in context, there is a, whatever the power is, probability of finding convincing evidence to reject the null. And so we talked about this in class. If we want to increase the power, and we saw that in the video on, what was that, April 3rd, with the applet. If we increase our sample size, that's going to decrease our the spread of our sampling distribution. That makes it easier to correctly detect that the alternative is different. Okay. If we increase our alpha, and so remember, this kind of goes back to the idea that alpha and beta are inversely related. So if we increase our alpha, and so I always like to write this because it helps me see it. If we increase alpha, that's going to decrease beta. We're going to lower the probability of a type 2 error. And because power is 1 minus the probability of a type 2 error, that means my power goes up. All right, so lowering alpha increasing alpha increases power. And then you can't ever control the distance to the alternative, but it is important to recognize that if the alternative, um, I don't like that language. No. If you can increase the distance from the null hypothesis from what the truth is, then that will make it easier to reject, right? So the further they're apart, the easier it is to recognize they're further apart. All right, so hopefully that explanation helps you out a little bit. Let's go back to our check your understanding questions. And so coming down. All right, suppose the true proportion of the invited guests that will attend the party is zero point 0.7, then the power of the significance test is 0.1. Interpret that power. So if the true proportion of all invited guests who will attend the party is 0 0.7. So if that is actually the truth, there is a 0.1 probability of correctly rejecting the null hypothesis. And so what we want to remember, and based on the notes we just looked at, we correctly reject when there's convincing evidence, right? So there's a zero point 0.1 probability of finding convincing evidence for the alternative hypothesis that P does not equal 0.75. I think in the note just a second ago, it said to put context there. You definitely always should include context in AP statistics, but I will note that I've already done context once, so I'm not going to feel the need to do it again. Don't hesitate to do that though. All right, so probability of a type 1 error. Type 1 error. That is also known as alpha, nice and easy, and that was 0.05. The probability of a type 2 error is, remember we said beta, but really it's just 1 minus power is how we're going to calculate it. And that's really all you're going to have to do on the AP exam is if they ever ask about probability of a type 2 error, it's just 1 minus power, or power is 1 minus the probability of a type 2 error. They will ask you more about the relationship of, hey, how do I create or have a larger power in this test? And so it's going back to those rules we identified of how we affect alpha, recognizing that if the distance between our statistic and our parameter is higher, then we have a greater chance of rejecting the null hypothesis, right? It's easier to get a small p-value, et cetera. That actually did show up on your DYU yesterday. But the probability of making a type 2 error, not great, 90%. I don't want that, but that's what it is for this one. All right, determine whether each of the following changes would increase or decrease the power of the test. Explain your answers. So remember, if we use alpha equals 0.01, I have now lowered my alpha. So that's going to increase beta. That's going to make it easier to make a type 2 error. So the power will decrease. And so one thing I will point out is again, I'm not as versed probably in power as I should be. It's always something I feel like I end up having to rush through each year, and I need to take some time over the summer to study it some more. But you can do distributions, and I believe statisticians do distributions. This is where I'm shaky. I know the content for the AP exam, but I believe statisticians will do power distributions like we did um, in the applet yesterday to find out the power at various specific statistics. However, what you really need to understand is what's going to happen to the power of the test if we change alpha, because that's important, right? You're going to need to know what happens to the power of the test if I change the sample size, things like that. So just keep that in mind. All right, if we use n equals 100, so remember, pretty much any time you increase n, you're going to decrease. So I'm adding if increase in. That means we're going to decrease the spread, right? Also known as variability. And I need to caution you, do not forget, this is not for any type of distribution. It's not true for the population distribution. That variability is set. It's not for the sample distribution, right? The distribution of a single sample, because if I have more data values, it's just as easy that that data gets more spread out-ish. But what we're talking about is we're going to decrease the spread of the sampling distribution. So power increases. Notice this does not affect the probability of a type 1 error because the only thing that affects the probability of a type 1 error is alpha. But it does affect power and the probability of a type 2 error. All right, that's it. That's the end of our unit. I am about to take advantage of some time I have to go do the AP free response questions that I asked you to do. So that will be in a following video right about now.